Imagine a world where energy is cheap and plentiful, where the power to fuel our homes, industries and cities is virtually limitless. Imagine a future free from pollution and the worries of climate change, where clean energy sources dominate the landscape. This is the promise of cold fusion, a theoretical type of nuclear reaction that could revolutionize our world by providing an almost inexhaustible source of energy. Unlike traditional nuclear power, which relies on splitting atoms, fission, and carries the risk of dangerous radiation and long-lived nuclear waste, cold fusion is envisioned as a cleaner and safer alternative, potentially eliminating the hazards associated with current nuclear technologies. It would tap into the immense energy released when atoms fuse together at room temperature, a process that could be both efficient and sustainable. The concept sounds like something straight out of science fiction, and for many years, that's where it remained, a dream in the minds of visionaries. However, the allure of a world powered by such a revolutionary energy source has kept scientists intrigued and searching for a breakthrough, driven by the hope of transforming our energy landscape forever. In 1989, two scientists, Martin Fleischmann and Stanley Pons, made a shocking announcement. They claimed to have achieved cold fusion in their lab. Their experiment, using a simple setup with palladium and heavy water, seemed to produce more heat than could be explained by any known chemical reaction. The news sent ripples of excitement through the scientific community and beyond. Could this be the answer to the world's energy problems? However, the initial wave of optimism soon crashed against the wall of scientific scrutiny. Scientists around the world rushed to replicate Fleischmann and Pons's experiment, eager to validate their astonishing claims. Laboratories buzzed with activity as researchers meticulously followed the reported procedures. They hoped to confirm the groundbreaking results, which promised a new era of energy production. But there was one major problem. The experiment proved incredibly difficult to reproduce. The initial excitement began to wane as more and more teams reported failures. Many attempts failed to produce any excess heat, a key indicator of successful cold fusion, while others yielded inconsistent or inconclusive data, leaving researchers puzzled and frustrated. The lack of consistent, replicable results led to widespread skepticism within the scientific community. Conferences and meetings were filled with heated debates and divided opinions. Cold fusion became a controversial topic, often dismissed as a scientific dead end. Media coverage added to the controversy, with sensational headlines and public debates. Despite the setbacks, a small but dedicated group of researchers continued to explore the possibilities of cold fusion. They worked tirelessly, driven by the hope that one day, they might unlock the secrets of this elusive phenomenon. Today, decades after the initial buzz, cold fusion research continues, albeit on a much smaller scale than in its early days. The initial excitement in the late 1980s, sparked by the claims of Martin Fleischmann and Stanley Pons, has given way to a more measured and cautious approach. Despite the setbacks and skepticism, a dedicated group of scientists remains committed to exploring this tantalizing possibility. While the dream of achieving a sustained and controllable cold fusion reaction remains elusive, there have been some intriguing developments. Researchers have made incremental progress, uncovering new insights and refining their techniques. These small but significant steps keep the hope alive that one day, cold fusion might become a reality. New materials and experimental techniques have shown some promise, and researchers are exploring different theoretical frameworks to explain the elusive phenomenon. Advanced computational models and simulations are being used to predict and understand the complex interactions at play. This multidisciplinary approach is crucial in tackling the challenges that have long hindered progress in cold fusion research. While mainstream science remains cautious, the potential benefits of cold fusion are too significant to ignore. Conferences and seminars continue to be held, where researchers share their latest findings and theories. These gatherings foster collaboration and inspire new ideas, driving the field forward. If cold fusion were to become a reality, it would have a profound impact on our world. Imagine cities powered by clean, abundant energy, free from the pollution and limitations of fossil fuels. The implications for our environment and economy would be transformative. It could provide a clean, safe, and nearly limitless source of energy, addressing climate change and transforming various industries. From manufacturing to transportation, the ripple effects of such a breakthrough would be felt across the globe, ushering in a new era of sustainability and innovation. While significant challenges remain, the pursuit of cold fusion continues to inspire scientists and fuel our hope for a brighter future. The journey is long and fraught with obstacles, but the potential rewards make it a quest worth undertaking. As research progresses, we inch closer to unlocking the secrets of cold fusion, holding on to the dream of a world powered by this revolutionary energy source.